You feel like your eyes are perfect video cameras, recording the world exactly as it is. They aren't. The raw visual feed hitting your optic nerve is actually upside down, is constantly shaking, and filled with static. Worse, that signal has massive physical gaps. You have natural blind spots, and your nose constantly blocks the center of your view. If the biological data entering your head is this chaotic and full of literal black holes, why does the room in front of you look so seamless? You never experience a raw feed of your surroundings. You are watching a highly stabilized, real-time edit constructed deep inside your skull. Your brain acts as a real-time prediction engine. It analyzes surrounding context, guesses what belongs in missing spots, and seamlessly paces generated pixels over the holes. Finally, it constructs color and depth, turning that flat signal into a smooth, three-dimensional world. But why guess at all? Why rely on a prediction engine instead of processing a perfect, absolute image? The answer comes down to extreme biological energy limits. Human intelligence runs on roughly 20 watts. That is less power than a standard LED light bulb requires to illuminate a desk. If we tried to build a computer to simulate that exact same processing power, it wouldn't run on a wall plug. It would require a dedicated power plant. Even at just 20 watts, your brain is a massive biological drain. It makes up about 2% of your total weight, but hogs 20% of your daily fuel supply, which is exactly why thinking hard leaves you physically exhausted. Predicting your surroundings instead of perfectly recording them is the ultimate biological hack. It allows human consciousness to run on a microscopic battery. The hardware starts with a single nerve cell, called a neuron, sprouting physical branches to send an electrical charge. Now, multiply that single cell by the 86 billion neurons inside your head. Each one makes thousands of links, exploding into a dense web of 100 trillion connections. A microscopic structure carrying so much data, it has far more physical connections than there are stars in the Milky Way galaxy. And this grid is constantly moving. As you practice a skill or form a memory, you force specific neurons to rebuild their own wiring, physically thickening and strengthening their pathways. Yet, for an organ that acts as the ultimate hub for every external distress signal your body sends, the brain tissue itself completely lacks local pain receptors. Because the actual brain is totally numb, surgeons can safely operate directly on the exposed tissue while the patient is wide awake and speaking. The rendering engine building your entire world is an unimaginably vast, physically shifting, and entirely numb web of flesh. This hardware is exactly why optical illusions are so effective. They expose the mechanics of your biological rendering engine. Here, you can see how an illusion is engineered. It is a specific visual pattern designed to feed your brain bad context. That bad context forces your prediction engine to guess incorrectly, generating a shape that isn't actually there. When an image completely tricks your eyes, you are not seeing magic. You are literally catching your own real-time rendering engine making a mistake. The truth is, you never see the universe directly. Everything you experience is just electricity moving through a numb 20-watt grid, continuously building a masterpiece of an illusion.